What really worries me today is what's going to happen to us if machines can think. And what interests me specifically is, can they?
Well, that's a very hard question to answer. If you'd asked me that question just a few years ago, I'd have said it was very far-fetched. And today, I just have to admit I don't really know.
Well, if you're confused, Doctor, how do you think I feel?
This is AI for the Rest of Us, a podcast from the University of Texas at Austin.
I'm Mark Earhart.
And I'm Casey Boyle.
This is a show that helps explain artificial intelligence, what it means, who it affects, and what you need to know right now.
I'm convinced that machines can and will think in our lifetime.
There is going to be all this automation. People are going to be out of work.
Computers are taking over now.
Here I am playing chess with a computer.
And then I just flick a switch on the modem and replace the receiver. I'm now waiting for the computer to answer me.
Today on AI for the Rest of Us.
Every time you're observing a data set, especially anything to do with images, ranging from astronomy to medical imaging, I think these fields are being transformed already because you have better telescopes, better images, and better microscopes.
The ability to solve climate problems by engineering proteins that are inside a bacteria with the right AI models and AI designs. Boy, that would really change the world.
We have two guests on our show today. Adam Clivens is a professor of computer science and the director of the Machine Learning Lab, which is a kind of umbrella organization for interdisciplinary AI research across the university. He also co-leads the Institute for Foundations of Machine Learning, which focuses on the fundamental theories behind AI.
And Alex Damakis is a professor of computer and electrical engineering. Along with Adam, he co-directs both the Machine Learning Lab and the Institute for Foundations of Machine Learning. Together, they're in a great position to talk about how AI tools and approaches can accelerate any kind of research you can imagine.
Well, Adam, Alex, welcome to the show.
Thanks for having us here.
Thanks for having us.
So you are AI researchers who help apply AI in all sorts of research disciplines, but you also work on the foundations of AI. That is, on the algorithms and the systems under the hood. If industry has a lot more funds to do this kind of thing, why is it so important that a university has its own models, its own facilities, and not just subscribe to one of these larger companies who may have more resources than we do?
We think this is an incredibly important thing that the universities and the open source community continue to make things open, because I am very worried about a world where only one or two companies know all the secrets and they obviously don't reveal them. And we can talk about open source quite a bit more, but I think keeping things open and keeping things principled is an extremely important part of how to have an open innovation system and an open academic system.
It's also important that if we want to ever really deploy AI models in the context of health, let's say that you've built a model that you want to try and use to predict if someone's going to get cancer. There are all these stories of people training models on one data set from one subpopulation or one hospital and then testing it out on a different subpopulation or a different hospital, and it fails. You have this problem of distribution shift or lack of generalization. So it's really important that you understand what data was used to train these models. And if the system is completely closed and you have no idea what data set was used to train these models on, then it becomes very hard to have insight on these questions of applicability across different distributions and generalization. And the more you understand how the model was trained and the more open the model is, the more insight you have.
All the language models that we know have been trained on data from the internet, basically that's scraped from everywhere on the internet, and a lot of it is copyrighted. What is happening right now is industry is not releasing data sets. Because if industry releases data sets, that's basically raising their hand and saying, sue me. But I think this is an important opportunity for academia to have a contribution because, for example, we are releasing data sets. We have released the largest multimodal data set, which is called DataComp, and now we're working on the largest language model data set, which is called DataComp LM. And we're also training models that are going to be like competitive with the Llama models.
Hey there, Mark here. Let me just pause Alex there for a second to explain what Llama models are. They're a set of large language models developed by Meta, the parent company of Facebook. They've released the models in such a way that researchers can open them up and see their inner workings. But Alex says Meta's models aren't entirely open. the data sets they were trained on are still secret.
But in addition to releasing the model weights, we are going to release the data sets. And that is, I think, an extremely important thing. There are a few nonprofits like AI2, the Allen Institute, that released recently a model and a data set, and also eLuther AI. But I think excluding these two, nobody else is releasing data sets. And I think data sets is a key for an open ecosystem.
UT should be the leader in the space of open sourcing AI models. And we're using a lot of all the computational resources that we pretty much have at UT to try and make that happen.
So as part of your work, you have launched a new center, the Center for Generative AI, and you're going to have a large new resource of a new set of graphics processing units, GPUs. Can you talk a little bit about that and sort of what are some of the kind of the partners you're looking to work with using that resource and what kinds of projects, things like that?
We realized that the need for compute in academia is tremendous. And with the help of the UT leadership of CNS, the College of Natural Sciences and the College of Engineering, we got an investment of compute that will be 600 NVIDIA GPUs of the latest and shiniest form. They're called GH200, Grace Hopper 200 nodes. So that would be supported by TAC, the Texas Advanced Computing Center. And it's providing, as far as we know, the largest compute available to a university. It's a tremendous amount of compute that allows us to train big models that otherwise we would not be able to train.
Yeah, 600 is a huge number for getting the latest NVIDIA GPUs. It's difficult to even buy one right now. They're in such high demand globally.
It's a very general question. What kinds of horizons does AI open up in research? What kinds of new questions, what kinds of new problems can we engage with the capacities of AI that we have today?
Yeah, I would say in terms of accelerating scientific discovery and engineering advances, when I was in school, I studied a lot of math and computer science, but I wouldn't say struggled, but never really enjoyed some of my science courses where there was a lab because I didn't like going into the lab and running experiments and waiting for them to finish and having to be very physically precise about what I was doing. And they're often very costly and time consuming. I always wanted to just write a computer program. And the idea that you can come up with a computer program that is using an AI model and have it simulate sort of laboratory experiments and have it be able to tell you, perhaps quite accurately what the outcome of the experiment is going to be is extremely powerful.
Let me add a few more things, like what are AI benefits in scientific research and academic research already? And I would say the most obvious one is the acceleration of coding. If you're quickly trying to see how to start something, it will give you a code. It will not work out of the box, but then you can just start messing around with it. And I think it will be a 5x to 10x acceleration. Beyond that, I want to say that every time you're observing a data set, especially anything to do with images, ranging from astronomy to medical imaging, I think these fields are being transformed already. And these are entering already the imaging pipeline. So they're accelerating scientific discovery because you have better telescopes, better images, and better microscopes. So you're seeing things better, and that helps already, I think. Beyond that, I think the one incredibly impactful thing is being able to understand the body of literature. So you can say, here is like 100 papers on this technical microfluidics kind of problem. I want to ask a question about this very narrow technical domain, and I want to ask a question to 100 papers. Right now, ChatGPT cannot do that. You have to use a combination of a language model and some retrieval mechanism on actual papers. But I think that will be one of the most transformative future uses, because that's actually also how my students are using me.
And you guys both lead a campus-wide machine learning lab. Can you talk a little bit about what that is and why there was a need to establish that?
I think the university realized that we really need a headquarters for machine learning and AI research on campus. And so we started this machine learning lab. We had got a big gift from Amir and Zaib Hussein to really start that up. And it's an organization that is the headquarters for AI research on campus, and it spans many colleges and departments.
we realized that there was tremendous interest across campus from the College of Engineering to the College of Natural Sciences to the business school. There's many faculty and researchers across all of UT Austin who are extremely interested in how AI will transform scientific discovery.
It's still a work in progress, but we have a lot of events and we seek out people who are both doing novel machine learning in their respective field and try to collaborate with them, try to find out what they're doing. So there's some information gathering that goes on, and then we set up projects to try and leverage expertise in different areas.
And just to kind of tag on to that, can you think of 2 or 3 just like really cool projects that people are doing that you're collaborating on, where it's like, hey, there's somebody doing this thing that we wouldn't have thought of?
We're trying to come up with new vaccines and therapeutics using AI, and that's a huge effort. We're calling it generative biology. That's a huge effort across multiple departments and multiple colleges, where you have a group of people who are really good at building AI models. You have people who understand a lot of very complex biology and chemistry, and you also have people who know how to work in a wet lab to be able to synthesize some of the designs that these AI models come up with. And you're trying to come up with new cancer therapeutics. You're trying to improve. We work with Jason McClellan, who was one of the inventors of the COVID vaccine. We work with him to try and come up with new, better vaccines for other diseases like RSV. So that's one huge effort that we have going on.
I can also tell you about an initiative we have about using generative AI to accelerate medical imaging, MRI. So we're working with John Tamir and Tom Yankelov and other experts here on campus. One of the problems with MRI is that the scans take a very long time. So they do not have enough temporal resolution to image, for example, a beating heart. Or if you try to scan a baby, the baby will not stay still for sufficient time. So you cannot do NICU, for example, scanning. But with AI techniques, you're basically able to fill in the gaps. So you can imagine in images, you may observe not a full image, but actually only 10% of the pixels, and then use a diffusion generative model to fill in the gaps. The diffusion model has been trained on other MRI scans, and it's tremendously able, and this has shocked me from the first day I saw it, that you can take an image of a human face, randomly delete 99% of the pixels, and still the model will be able to fill in the missing pixels with almost no visible degradation. So this is something that we kind of knew, that natural images are compressible, but we have been surprised by how compressible they are, especially if you stay in one narrow domain like faces or brain scans. We have observed, similarly to the natural images, that you can subsample MRI brain scans, allowing you to accelerate 4 times or 8 times. So, we think they will be tremendously important in the future of all medical imaging. I think there will be some AI.
In astronomy, they're trying to figure out major questions surrounding stellar formation, how stars evolved, how galaxies evolved, what mechanisms were at play there. And they're using all kinds of generative AI models to understand the observations that we get from various telescopes. And I think that's amazing and exciting.
Yeah, in the iSchool, Yingding is leading an effort to create like a medical ChatGPT, as far as I understand, a language model that you can ask medical questions and get reliable, correct answers the way you would call a nurse if you have a help desk. And I think that, of course, you can already also do that on ChatGPT, but the problem is you want the model to be very safe, that you want the model to acknowledge its limitations. You want the model to have accuracy compared to relevant literature, as opposed to conspiracy theories and so on. So there's a lot of things you have to make sure you get right. And you can also see how this is tremendously useful thing. Even if 10% of the time it says you should call an expert, I don't know.
So if you think about the way scientific research is normally done, scientists, design experiments, they ask questions, they do the experiment, they look at the data that they get, they analyze it. And we've already seen that AI is starting to help with, interpreting and analyzing data. But do you think there's going to be a time where, AI can take over more of the scientific discovery process? In other words, do you think there will be a time where you can point to a discovery and say, this AI system made this scientific discovery? And if so, who should get the credit?
Well, we already have some of that. This, what I consider to be maybe the great success story of AI is this AlphaFold program that Google DeepMind created. We're now at AlphaFold version 3, where, it used to take a PhD student 5 years. It would be their entire PhD thesis to figure out, given an amino acid sequence, what does the actual 3D structure of that protein look like? Very complicated X-ray crystallography. And now we have this program that can do it in a couple minutes and is very accurate. It's not perfect. It still makes mistakes and has difficulties doing all of the things that we would like it to do, but certainly has been a major breakthrough and has enabled rapid prototyping of certainly, new vaccines, but also I would say, thinking a little bit more sci-fi, the potential for biomanufacturing. Like imagine that you could take some pollutant that you want to get rid of and put it in a vat somewhere and have a bunch of bacteria in there and have it just ferment like you're brewing beer or something. And out comes a very complicated cancer drug that would otherwise be very expensive and toxic to produce. That's sort of, I think, the dream of biomanufacturing. And there are companies out there, like LanzaTech is a company that takes carbon monoxide and puts it in a vat and produces ethanol glycol. And from that, you can make yoga pants. So famously, they sort of hold up, polyester yoga pants that were made from 100% carbon monoxide. But the ability to solve climate problems by engineering proteins that are inside a bacteria with the right AI models and AI designs and have them sort of be able to do chemical reactions on demand in a totally pollutant-free, carbon-free way. I mean, boy, that would really change the world. And I'm a believer in that technology, and we just need the data sets and the architectures and the algorithms to get it to work.
Well, I want to thank you again for being here today, and it's a really interesting conversation.
Thank you.
Thanks, Mark. Thanks, Casey.
That's our show. Next time on AI for the Rest of Us.
Before it was disclosed to patients that they were speaking with a robot, they were reporting a fairly positive healthcare experience. But once it was disclosed to them, all of that went away.
AI for the Rest of Us is a production of the University of Texas at Austin's College of Natural Sciences and College of Liberal Arts. Our show is part of the university's Year of AI. To learn more, visit yearofai.utexas.edu.
For links and more resources on today's topic, go to aifortherest.net.
Big thanks today to our guests Alex Demakis and Adam Clivens. Our executive producers are Christine Sinatra and Dan Oppenheimer. Sound design and audio editing by Robert Scaramuccia. Our theme music is by Aiolos Rue. Our interviews are recorded by the fabulous audio engineers at the Liberal Arts ITS Recording Studio.
Thanks for listening.